In this section, we will talk about tuples. Tuples are so-called composite values, which means they are made of several values. For example, let's say that you want to store data about a particular person in one place. Let's take a look how to encapsulate such information in a tuple. We've defined an identifier look containing our tuple. Inside it, we stored his first name, last name, and occupation. A tuple is typed structurally. This means that even if we don't annotate data of our tuple with an explicit type, the compiler can still deduce it by looking, for example, at its content or its usage. In our example, you can see that the compiler inferred the type of our expression. It's telling us that it's a tuple of size 3. These three parts of our tuple are called components. So, our tuple is composed of 3 components, and each of these components has a type of string, as you can see here. So, thanks to type inference, you're pretty flexible when defining your tuples, since you don't need to declare your types manually all the time. Let's write some more tuples. We created a new tuple called Han, which has the same structure as the previously defined look tuple. We can also write the same code by first introducing a type identifier representing a person type. Here, we are using the person type identifier to constrain the type of the look and Han identifiers. As a result, both these identifiers are of the type person, which is a tuple of strings, as you can see here. Let's take a closer look at tuples. Tuples are immutable, ordered, and fixed-sized at creation time. They can also contain different types of values. So, the simplest way to aggregate several values is to join them in a tuple. We need to keep in mind that there is no tuple of size 1. In such case, we would just use the value itself. As we've just seen in our example, at the level of types, here, we can compose 2 types to form a tuple by using a comma. At the level of expressions, when creating a tuple, we also separate the expressions by commas, as you can see here. Now, let's talk about pattern matching. We can use pattern matching for many scenarios in Reason. For example, we can use it for a case analysis or for the structuring. Now, we will talk about the structuring, or in other words, we will use pattern matching to extract values of a tuple. In general, we can use it to extract values of any data structure in Reason, as we will see later. When the structuring, we use patterns to describe how values are extracted by our program, and we can use them in let bindings and as function arguments. The simplest form of patterns are identifiers. Here, we are extracting the value of 6 by naming it num. Another way to extract a value is to ignore some components using the wildcard pattern, which is written using underscore. Here, we are basically saying that we ignore the value of 6. Let's talk about pattern matching with tuples. Tuples aren't meant to be updated mutatively, meaning when you want to change them, you need to create new ones using pattern matching. Patterns can be composed together to describe the extraction of tuples. As you can see, we are using lead binding for our pattern matching. We are extracting the first component of our tuple, which is 5, by naming it x, and we are ignoring the second component of this tuple, which is 10, using underscore. A pattern that matches a tuple is defined the same way as a tuple itself, meaning it's composed of subpatterns separated by commas. The number of subpatterns must be equal to the number of tuple components you are pattern matching. In our case, we have 2 tuple components, so we've defined 2 subpatterns. Let's now try to extract values of an identifier containing a tuple. We've defined our tuple composed of 2 components, 25 and 21, and bound it to an identifier called nums. Let's try to extract the first component and call it x. If we want to name the first component of this tuple x and to ignore the second component, we just use the pattern that starts with an identifier and which is followed by the underscore. This pattern can also be used as an argument of a function. This is a general function that always returns the first component of any pair. In our case, we get back 54. This function is polymorphic, which means it can take values of any type. Let's define a function that will return the second component of any pair. We've defined a new function called getSecond. And again, this is a general function that always returns the second component of any pair. In our case, we get back 2. Let's take a look at some typical use cases for tuples. You would use tuples in situations when you need to handle multiple values. For example, when you need to return several values from a function. Here, we returned first name and last name inside a tuple. Another very typical example is pattern matching using a switch expression. As you can see, we are defining our data as well as our patterns as tuples. You don't need to understand what's going on here for now, since we will be talking about pattern matching using a switch extensively in one of the upcoming sections. Let's talk about some typical errors we can get when using tuples. The first category of possible errors is related to the invalid RD. These errors are caught by the compiler at compile time. So you have the guarantee that during the execution, the program will not fall into these kind of problems. Let's take a look at an example. We got an error since we used not enough subpatterns with respect to the number of components of the tuple we are using. So if you write a pattern which is expecting 2 components and you try to access a tuple with 3 components, you will get an error from the compiler telling you that the 2 types of the pattern and of the expressions are incompatible. Let's take a look at another error we can get. Here we have another error, since we can't use the same identifier several times in a pattern. In our example, we try to give the same name X to two components, as you can see here. The second category of possible errors is related to the fact that we are referring to the tuples components using their position. And this kind of error can't be caught by the compiler because it is a semantic issue. The getFirstName function expects first name, last name, and occupation values inside a tuple as an argument, and returns the first name value. However, when we called the function, we made a mistake, since we passed the occupation first and the first name second. As a result, our function returned occupation and not the expected first name. And this is a semantic error, since we passed tuple values in the wrong order. So the compiler is not able to understand that this is an error. Fortunately, another reasons data structure called record will help us to avoid these kinds of errors. And we will talk about records in the upcoming section.